This is the client-side track. You're in the Augustus 5-6 room. Today, presenting is Hacking Browsers DOM, Exploiting Ajax and RIA. The presenter is going to introduce himself. Please welcome him.
Thank you. Thank you very much. Going to talk on hacking browsers DOM. Before that, I will just introduce myself. I'm a founder and director of a company called BlueInfi. So we are specifically focused on application security, 8443. So everything which we do around that. Previous experience, NetSquare, Foundstone, Chase, IBM, etc. And my prime interest is web security research. So we do a lot of research on that, come with the tools, techniques, methods, etc. And today I'm going to walk through some of the tools, and we are introducing two new tools today. DOM Scan and DOM Tracer. So we'll look at that as well, and then you can download and play around. These are some of the published research by me on security focus, O'Reilly, DevX, InformIT. So I'm writing some columns and stuff like that for them. These are some of the tools: WS Scanner, Scan Web 2.0, etc. So some of the tools we are going to cover during the presentation. And these are some of the books written by me on web hacking, hacking web services, and Web 2.0 security. So this is the agenda for today. We'll start with attacks and trends, very small piece where we focus on importance of the DOM and how it is coming in. We'll look at some of the cases, client side and patterns. We do a lot of assessments and audits, and we have on-demand scanning going on. So in last 2 years, we come across a lot of 2.0 applications. 50 to 60% of applications coming for the review are essentially 2.0 kind. Then we'll look at DOM and application architecture, how DOM fitting into next generation applications. So we'll look at layout, browsers, DOM attack surface, and then we actually look at DOM-based attacks like DOM-based XSS, widgets hacking, feeds, mashups, injections, etc. So the focus here is definitely the 2.0. So 2.0, be it Flash, Flags, or such. And then we briefly touch upon some of the defense and countermeasures and end with conclusions and questions. I have a lot of demos lined up, so I will try to play those demos whenever it's required. Okay, so first move on to the attacks and trends. In last couple of years, we reviewed a lot of applications, be it banks, portals, telecom, etc. And when the application is a 2.0, which is using Ajax, Flash, Flags, Silverlight, what we are looking at is a very complex usage of DOM. DOM is essentially a document object model, which is a part of your browser's rendering component. So developers are using DOM very innovative way, dynamically changing DOM, and they are integrating a third-party libraries like, say, Dojo or GWT or DWR or such. So these libraries would be using this DOM in a pretty complex way. And then we detected a lot of vulnerabilities like XSS with DOM, widgets and mashups from the DOM, logic bypass, lot of different attack vectors which we defined in this area. And recently, like some of the published vulnerability, like you have a multiple DOM-based XSS in Dojo toolkit, or you have a Yahoo Mail or such. So there are a lot of reporting coming out which is focused on DOM-based cross-site scripting and DOM-based vulnerability. And we'll see how there are no sufficient or enough tools or automation out there to address DOM-based vulnerabilities as such. So we try to address that as we go. Client-side attacks are on the rise. There is a lot of statistics out there. Malware and attacks are completely focusing on the browsers, and then there are various different components of the browsers out there, maybe a plugins or maybe the underlying components or maybe a DOM. So that's a little piece which we are focusing during the presentation. DOM is an active part of the browsers, and it's essentially a popular attack point. As we know, like XSS is a major threat which we are looking at, and we have a persistent, non-persistent, and DOM-based 3 type of cross-site scripting. But with the DOM-based cross-site scripting embedded into a Web 2.0 application will become a permanent XSS, because the DOM is going to stay there for the rest of the life cycle of the application. We'll see what little difference is there. We are looking at the CSRF over 2.0 components like AMF or XML or JSON or stuff like that. So that's an interesting area which we are looking at. Some of the Web 2.0 components like say widgets or mashups or feed reader, etc., is actually opening up some of the attack surface on 2.0 applications. So this is a brief trend which we are looking at. The focus here is again a DOM, how DOM is integrated into the application, what kind of a calls it is making. So this is a trend which we are looking at. WASC, Web Application Security Consortium, comes up with some of the data, and definitely like we have a 39% cross-site scripting, and then we have information leakage, etc. And some of these things can be extracted from DOM, like maybe a DOM-based cross-site scripting or information leakage coming through the DOM calls, etc. And these are the attacks which are occurred in last year, and there is a client element there, and we'll look at how DOM has to play in this particular scenario. So this is kind of a trend which we are looking at, and definitely on the top there is a cross-site scripting, but along with there are different attack vectors which are generated from DOM manipulations and DOM attacks. If you look at the OWASP top 10 from 2004 to 2007 and 2010 and how the whole AppSec dynamics changing, we are looking at the injection on the top. We have a cross-site scripting. Then we have a new introduction of, say, unvalidated redirects and forward. Now, across these attack vectors, there is a DOM which can play a role, or a DOM would be playing a role. For example, you have a injection. You have SQL injection over JSON, for example. This particular call is actually going from the DOM over API, or cross-site scripting, where DOM-based cross-site scripting would be playing role. Broken authentication and session management, when the functions are getting called via DOM, and if these functions are not yet already the function is already published, and once it is getting loaded in the DOM, you can make call anytime. Unvalidated redirects and forwards can be linked to a DOM. So essentially, these are some of the elements where in OWASP top 10 there is a usage of document object model or a DOM. So if you look at the architecture and how DOM fits in, so here, for example, you have an application right here, for example, a dummy application here. So this is an application where browser loads the page, loads the whole HTML page over here. So you have HTML page here, and this is a plugin called Firebug, where you actually look at some of the components of your browser. So you have this HTML page here, and this is what you are looking at is all the DOM structure. So this is a document object model and all different. So every pixel over here, what you are seeing, can be controlled from the DOM. So you can change, manipulate anything which you want to say. For example, you want to change a value here. Say instead of a catalog, you want to write something else. But programmatically, you can write using DOM calls. So this is how DOM get implemented. You can start inspecting components here. For example, where this particular link is, you can see over here, or where this essential text over here, you can actually see this is okay. This is in HTML, and this is in a DOM node. So this is essentially a document object model which we are looking at. So if we look at the Web 2.0 application in detail, then you have the browsers where you have a Ajax. You have a RIA, that is a Flash and Silverlight running there. You have HTML, JS, DOM, etc. So the whole browser, be it any browser you take, it's running with various different components and pretty rich in scenario. And it will make a request to the application, and assuming that this is a typical Web 2.0 application which is using DOM extensively, is going to throw a DOM, one first page DOM to the client, and then from that various different calls are going to come back and forth. So from that you can actually go and access mails, news, documents, whether banks, trades, RSS feed, etc. So this is essentially where everything is now needed through the APIs. So you can make a SOAP API to search Google, or you can make a SOAP API to read CNN news, etc. So this is how you're going to the one application, and from that particular application you are accessing all different applications which you are accessed during your day. So we have like a internet where we have a network of networks. The 2.0 is more like an application of applications, and it is enabled with the SOAP. You can call object, and you can turn your application into the web services as well. So you publish your endpoint, and your application will become a web services endpoint for someone else. So then this is the whole application architecture become very thin. You have a very thin database and authentication, and then you are trusting various different data sources and integrating them into your application via widgets or any other technology which you are using. And then you have You have a direct calls is also possible. You can make a cross domain bypass and make a call directly to the blog or such. So there is a whole SOP or same origin policy involved there. So this is how your DOM usage will happen, where when you load a Web 2.0 application, your DOM usage would be pretty complex, and we see how complex it can get. And when we focus on the layout, you have a rich client and web client. A rich client may be written in JavaScript, or rich client which is actually manipulating a DOM, and then you have a typical web client over there which is part of your browser, which would be you are accessing. Then you go to the DMZ, your web server is running there, you make HTML, etc. Access backend application server, it will access database, and this is how the whole 2.0 application will get access. And then you have a Web 2.0 resources sitting there, maybe web services or JSON RPCs or XML RPCs or whatever. So you have that component there, and your rich client will directly make calls to these and fetch information from the server and change the DOM. So essentially, every click you make, you don't have to reload the DOM. There is no refresh and reload the page. Once the DOM is loaded in your browser, the application will remain as it is for the rest of the time. So say, for example, you stay on that particular page and spend 30 minutes, your DOM is not going to change any time. You just make a call, it will generate a call at the back end, it will grab the information and show you on the DOM. So this is how the 2.0 DOM will interact with the 2.0 resources at the back end. So these are the few demos which I can show you here. For example, you have over here a simple application called, say, pageflags.com, and you have this Firebug running at the down over here. Now you can see in the application what is happening is things are getting loaded over here. So it's like a one-page application. It's a slash. You go to the slash and you have this particular application coming up. And over here, the calls which you are looking at is an Ajax call. They are the XHR called XMLHttpRequest object calls. So JavaScript will make these calls one after another. And you can see when you load this particular page, almost 130 calls which go at the back end and fetch various different information over here. So you can see all these different calls, different structures. Now some calls are going to SOAP, some calls are going to JSON, some calls are going to the weather context, etc. And you have all these different DOMs and all these different widgets. So you have like a one DOM but multiple applications running there. So this is how the application will actually work. And then if you dissect the application and try to see what is at the back end, what I'm doing over here is I'm just downloading that particular page. It's a one-page application as such. There is no second page or third page on this particular application. So it's a one DOM application. So I'm downloading the page and storing that particular page on my browser, on my local system, and then I try to run. This download is complete, so I'm taking the backend JS files as well. So I'm taking all JavaScript files, etc., from the server, and try to see what is going at the back end. So we have the page downloaded over here, and now I quickly run few commands and grab here. So I'm saying, okay, show me all JS files. So this is my list of JS files, and now I say, okay, show me all my ASMX files. So these are the ASMX files. ASMX file is essentially a backend resource for the web services. So each of these ASMX files which you are seeing is a web services by Microsoft platform which runs on ASMX. So then each ASMX file would have more than 100, 200, 300 functions. So DOM will make these calls to the ASMX files and retrieve the information what it is looking for. So this is a Microsoft technology, ASMX. Similarly, like everyone has these kind of technologies in place. For example, over here you have a DWR library, something called Direct Web Remoting Library, and at the back end you have a struts running, or struts applications running. So you can see this application, again, every time you will remain on /trade. You don't go out from the /trade. Whatever you are doing in that particular DOM only. So you can see all the XHR calls going over here. These are not the typical HTTP driver calls. These are like an Ajax call through the JavaScript. You use XHR object, make a backend connection to whatever server you are running on, and make a call and retrieve information. Whatever you want to retrieve, pretty much you are retrieving this information from the XHR call. So this is how essentially DOM is going to get utilized. So you go through the site will give you the one HTML page where the complex DOM is there, and then it will throw you 20, 30, 50 JavaScript files, and then whatever you are doing is you are playing around that particular DOM only. So this is how the browser would look like. You have a browser where you have a JavaScript, core XML parser, network graphics, etc. would be sitting, and then you have a browser engine where user security